pressure, depth and volume. In the previous chapter, you learned that an essential feature of the mask is that it incorporates the nose so that it can be pinched closed from the outside. These features of the mask derive from an extremely important phenomenon for us freedivers: the increase in pressure with depth. But what is pressure? In physical terms, pressure is the force acting on a surface. Think, for example, of our planet. Wherever you are, there is air around you. Due to the force of gravity, the air molecules are attracted downwards. That is, they have a weight. This means that every layer of molecules supports the weight of all those above. The weight of the air above bears down evenly and in all directions on the bodies pushing on their surface. This push is called atmospheric pressure. At sea level, the atmospheric pressure is worth 1013 hectopascals. For simplicity, however, we will continue to use the old unit of measurement of 1 atm, atmosphere. If you climb up a mountain to 3,000 meters above sea level, the weight of the overlying molecules of the layer of air where you are is less. At that altitude, the atmospheric pressure is lower than it is at sea level and is about 0.7 atm. In water, changes in pressure happen very quickly and involve quite unusual situations and procedures. Pressure in salt water increases linearly with the depth. It increases by roughly 0.1 atm every meter. To create a pressure of 1 atm, like that originating at sea level from all the Earth's atmosphere, a column of salt water just 10 meters high is sufficient. The pressure generated by the water is called hydrostatic. We divers, on the other hand, are interested in measuring the total pressure at the depth we are at. We will therefore use the absolute pressure, which is the sum of the hydrostatic plus the atmospheric. At 10 meters of depth, you are already at a pressure that is 1 atm higher than that on the surface. That is at an absolute pressure of 2 ata. While on reaching 20 meters, you will have 2 atm more, meaning an absolute pressure of 3 ata. Diving under the water, the increase in hydrostatic pressure is immediately perceptible to the tympanic membranes. It is not easy to perceive pressure changes in the rest of the body, as it is made up of solids and liquids that, in practice, reach the new pressure without any variation in volume. The parts of our body that can be affected by the phenomenon of compression are the gaseous cavities. If we took a balloon full of gas under the water, we would immediately see that as it goes down, its volume is reduced. The volume change in the balloon is inversely proportional to the absolute pressure. This means that if the absolute pressure doubles, the volume of the gas halves. If the absolute pressure triples, the volume becomes a third. To understand the effects of pressure on the body, we also need to consider whether a cavity is connected with the outside of the body directly or through a membrane. If you take a bucket under the water, keeping the opening downwards, the increase in pressure causes a reduction in the volume of air, with the water entering the bucket. If instead you descend with the bucket closed with the plastic membrane, the force of the hydrostatic pressure will curve the plastic film towards the inside of the bucket, introflexion, to try to equalize the internal pressure with the external one. As you descend further, the membrane stretches to the maximum, resisting the action of hydrostatic pressure. Inside the cavity, the pressure is lower than that outside. We are therefore in a situation of baric imbalance in compression. Because the pressures are different inside and outside the cavity, and this inequality has occurred during the descent, that is, in compression. This situation can only last until the membrane, now stretched too tightly, breaks due to the still increasing pressure. In order to avoid pressure imbalance, you have to find a way to emit gas into the cavity, equalizing the internal pressure with the external one. This operation is called equalization.